I just need some place where I can lay my head.
In section 2.2, we're going to look at multiplication and division of rational expressions. Remember, a rational expression is of the form a over b. It's like a fraction. So you need to remember how to multiply fractions. Do you remember? I hope so. Think of if you had a fraction like a over b and you multiplied it by a fraction c over d. How would you do that? Well, it's quite simple, isn't it? You just multiply the two numerators together, so you get ac, or a times c if you want, and you multiply the two denominators together, so you get bd, or b times d. And the wonderful, wonderful news about multiplying rational expressions, or multiplying fractions for that matter, is that you do not need a common denominator. That's good news. You do not need a common denominator. Okay, so when you're multiplying rational expressions, there are 4 steps to follow, and you must follow them in this order. Step 1, factor the numerators and the denominators. Step 2, find the non-permissible values, NPVs, right? We talked about that last day. Next, you simplify, ninja slice, I'll talk about that in a second. And 4, you multiply. Let's just talk about this ninja slice for a second. If you were multiplying some fractions together, like 2 over 8 times 3 over 4, for example. You could just go 2 times 3 is 6, 8 times 4 is 32, and then you'd have to worry about putting it in lowest terms. You could certainly do that. But remember, you also could cross-cancel, some teachers call it. I actually don't like calling it that because it doesn't only have to be cross, it can also be up and down. Or a couple years ago, my grade 8 started calling it ninja slicing, and I've kind of enjoyed that. So if you're going to ninja slice here, what you need to look for is one number on the top and one number on the bottom that you can divide by the same thing. So I see that I could divide 2 and 4. I could divide them both by 2. It would leave me with 1 up here, and it would leave me with 2 down here. 4 divided by 2 is 2, 2 divided by 2 is 1. Now I can multiply. 1 times 3 on the top is 3, 8 times 2 on the bottom is 16. I'm done. Let's do the same question again. I want to show you that you could also have done it this way. One number on the top, one number on the bottom. Divide 2 by 2, you get 1. Divide 8 by 2, you get 4. 1 times 3 is 3. 4 times 4 is 16. We got exactly the same answer, 3/16. Okay, that's ninja slicing. And it's optional, but it'll really make your life a lot easier if you do it when you're dealing with these rational expressions. Okay, first step is to factor the numerators and denominators. So in this question, you have monomial, 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 monomial. You cannot factor monomials. So you're done step 1. You can't factor. Step 2, find the NPVs. So NPVs, non-permissible values, right? You look at the denominators and you ask yourself, what would make the denominator equal 0? So what would make this first denominator equal 0? Well, if x was 0, that wouldn't work because you have 3 times 0 times something else, and 3 times 0 times anything is still 0. So x cannot equal 0. That's the same over here. You couldn't have 0 here as well because 8 times 0 is 0. You don't need to write it twice. It's fine. There's also this y. What could that y not be? That couldn't be 0 either. Otherwise, the whole denominator here would be 0. So your NPVs are x can't equal 0, y can't equal 0. Great. Now we're going to simplify by ninja slicing. They don't have to. You could multiply 4x squared times y squared. You could multiply 3xy times... But I just think it's a little simpler just to do this right now. So can you find one number on the top and one number on the bottom you could divide by the same thing? You're probably looking at the 4 and the 8. You could divide them both by 4, not 2. You want the biggest number possible, so it's 4. 4 divided by 4 is 1, 8 divided by 4 is 2, and that's it for that. Is there anything else you could divide by or cancel out? There is. You can look at letters too. How many x's do you have in the numerator position? 2. There's 2 x's up here. How many in the denominator position? 2. 1 over here and 1 over here. In other words, these 2 x's can be canceled out by this x and this x. Great. Anything else? Yes, we have y's. How many y's up here? 2. How many y's down here? 1. So we could cancel 1 out in the bottom and also 1 out in the top, which just leaves us with this one here. Okay, that's a lot of stuff that I canceled out. You have to do this neatly. You have to be organized. You got to think, and you can do this, but you don't have to if you'd rather multiply it out first. So what I'm left with is 1 times y on the top, it's just y, and on the bottom I'm left with 3 times 2, which is 6. So I get y over 6. And then I also want to remind myself that x cannot equal 0 and y cannot equal 0, and I'm finished. Okay, the next question. Ay, 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 look at all the factoring. You can factor each one of these things. This is what I said. You must know how to factor. This course is a nightmare if you can't factor. Imagine having to do this question if you're not awesome at factoring. You would not like it. Okay, so the first one up here is a simple trinomial. You're looking for two numbers that multiply to 12 and subtract to 1. I mean, I don't want to do this every time, but I guess I could do it for one or two of them. Two numbers that multiply to 12, these ones, and subtract to 1, it's that there. So we know it's going to be A, and it's 4 and 3. Put the big number first, the small number second, drag that minus sign down. A minus times a what equals that minus? A minus times a plus. Okay, we're done that one. Let's look at this bottom one. This is a difference of squares. We're looking for something that multiplies by itself to get a squared. Well, that's a and a. Something that multiplies by itself to get 9. That's 3 and 3. What are the signs? One's plus, one's minus. Now we have our multiply. Keep going here. We're going to multiply this. This is another simple trinomial. So we're looking for two numbers that multiply to 3 and add to 4. That's 3 and 1. So I have a and a. 3 and 1 are my numbers. Drag down that sign. A negative times a what equals a positive? A negative times a negative. Next step. This one looks like it's a binomial, but it's not a difference of squares. What should I be trying to do first every time, which I always forget to say? Take out a greatest common factor, and the greatest common factor is a. What's left? Well, a times a is a squared, and a times negative 4 is negative 4a. You can't factor this anymore. We're done. Alright, that was all step 1. Now we're on to step 2, which is find the MPVs. So remember, you want to do this in order. You don't want to do this after you've canceled a bunch of stuff out. You want to do it before you cancel stuff out. So what we're left with is all these factors in the denominator. A plus 3, a minus 3, a and a minus 4. What would make that one equal 0? If a was negative 3, that wouldn't work. What would make this one equal 0? If a was positive 3, you could write positive 3 here, or you can just make it plus or minus 3. That means positive 3 and negative 3. What would make this factor here, this a in brackets, I'll put it, what would make that one equal 0? Well, if it was 0. And what would make this one equal 0? If a was 4. So there's actually 4 MPVs. A can't be 3, negative 3, 0, and 4. Okay, we're ready to cancel now. So you're looking for things that are exactly the same. Remember, you can cancel binomials if you have exactly the same binomial on the bottom. I see an a minus 4 and an a minus 4, gone. I see an a minus 3 and an a minus 3, gone. Is there anything else? Yes, there is. This is why I don't like to call it cross-canceling. These two are not across from each other, but you can cancel them. One's on the top, one's on the bottom. They're gone. So there's not much left. The only thing that's left is a minus 1 on top and this a on the bottom. Don't forget your MPVs. A cannot equal plus or minus 3, it can equal 0, and it can equal 4. Next one, got to start by factoring. The first one up here is a simple trinomial. Two numbers that multiply to 4 and add to 5. That's 4 and 1. So we've got x, and the numbers are 4 and 1, and drag down the plus, and a positive times that positive equals that positive. Okay, I'm going to do this one over here. Here you can take out a greatest common factor of 4, and you're left with x minus 2. 4 times 2 is 8, right? Okay, I'm going to go to this one. This is a difference of squares. So what multiplies by itself to get you x squared? X and x. What multiplies by itself to get 1? 1 and 1. Make one positive, make one negative, you're done. Okay, this one, probably take 2 steps. This is not Bobby Bridge. What's the first thing you should do in this one? You should factor out a greatest common factor. I don't know if you want to write this here. It's going to factor out a 2. So what's left? 2 times x squared equals 2x squared. 2 times negative 4x equals negative 8x. And 2 times positive 4 equals positive 8. Okay, great. Now we can factor this. The part in brackets is the difference of squares. So we have x and x to get the x squared. What multiplies to give 4? Two numbers that multiply to give 4 and add to 4 as well. Well, that'd be 2 and 2. Bring that negative down. Negative times a what equals that positive? Negative times a negative. Don't forget that 2 that comes along for the ride. Okay. Now you could go one more step here and make it 2 times x minus 2 squared, but I'm going to leave it like this because I'm now going to cross stuff. I'm going to cross stuff out in a second. But before I cross stuff out, I want the MPVs. So we look at the denominators. What would make this factor, the 2, 0? Nothing. That doesn't make sense. It's 2, so forget about that one. What would make the second bracket equal 0? If x was equal to 2, it wouldn't work because then you'd have 0 there. What would make this one equal 0? 2 again. You don't have to write it a second time. What would make this one equal 0? Negative 1. What would make this one equal 0? Positive 1. Why don't I just put plus or negative 1? Okay, time to cancel stuff out. X plus 1, x plus 1. X minus 2, x minus 2. Oh, a 2 and a 4. Could divide them both by 2. I'm left with 1 and I'm left with 2. And I think that's it. So you have x plus 4 times 2, or 2 times x plus 4. Just leave it factored. You don't need to multiply it through again. This is fine. You can if you want to do mountains here, but this is great. And you also have on the bottom have x minus 2 and x minus 1. Again, just leave it all in factored form. That's totally okay. X cannot equal plus or minus 1, and it also can equal 2. Those are our MPVs. And we're finished. Okay, on to dividing. So, a reminder with dividing, if you had something like A over B and you were dividing it by C over D, do you remember what you do? You probably do. You keep the first fraction exactly the same, then you actually aren't going to divide, you're going to multiply, and you take the reciprocal of this, you flip it, so it's D over C. Again, the good news is you do not need a common denominator. That's fantastic. And there's another point that's very important. When you're looking for the MPVs, I have no idea why that's look in for the MPVs. You must look at all denominators, the ones that you have before and the denominators you have after you flip the second rational expression. So I'll show you what I mean in just a second. So we start by factoring again. The first one up here is a difference of squares. So x times x equals x squared. 2 times 2 equals 4. Make one positive, make one negative. Here we can take out a greatest common factor of x, and you're left with x minus 4. Nothing else you can do there. Divided by, I know I could flip it here, but I want to show you why I'm not doing that. This is a simple trinomial. So it's going to be x and x. Two numbers that multiply to 6 and subtract to 1. Multiply 6 and subtract to 1 are 3 and 2. So 3 and 2. Drag down that plus. A positive times what equals that negative? A positive times a negative. And this is also a simple trinomial. So again, x and x. Two numbers that multiply to 20 and subtract to 1 again. It's going to be 5 and 4. Big number first. Drag down the plus. A plus times what equals that negative? A plus times a negative. Okay, now I know you're going to just like roll your eyes and scream and go, no way, I'm not going to do that, that's crazy and everything. But I'm now going to flip it. I'm literally going to rewrite this whole thing, put a time sign or whatever, and flip this. So the x plus 5, x minus 4 comes to the top, and the x plus 3, x minus 2 goes to the bottom. Now you could skip one of these steps if you want, but I need to show you now that for the MPVs, you need to get the MPVs from all the denominators. So if you look over on this side, this was a denominator here, and it's still a denominator here. But on this side, this was a denominator there, and then we have a new denominator down there. So we actually have to look at kind of 3 denominators. This one, which is the same in both cases, so that's 1, 2, and 3 places you have to look for the denominator. Now, you might be wondering why we have to look at the x plus 3x minus 2. I mean, in the original question, it's not even a denominator. But here's the thing. If you did have the numerator here equaling 0, if either this first factor or the second factor equals 0, then it would be 0 divided by something. So this whole amount right here, this whole fraction, 0 divided by some amount would equal 0. And then if you look at the whole question, you'd have some amount here divided by 0. You can't divide by 0. So this is the reason you have to take that one into account as well. So basically, there's a whole bunch of NPVs here. We look at this first one. X, what would make that equal 0? Well, if x is 0, so we can't have that. What would make this one equal 0? If x is 4. What would make this one equal 0? Remember, we have to look at all the denominators. If x is negative 5. What would make this one equal 0 if x is 4? What would make this one equal 0? Oh, we already had 4. I don't need to write that again, do I? So I'll erase that. What would make this one equal 0 if x was negative 3? What would make this one equal 0 if x was 2? Wow, 5 different non-permissible values. Okay, time to cancel. Ninja slice, we look down here. X minus 4, x minus 4, x minus 2, x minus 2. I think that's it. So we'll just leave it in factored form. X plus 2, x plus 5 on the top. And then here we have x times x plus 3. And the non-permissible values. X cannot equal 0, 4, negative 5, negative 3, and 2. All finished. Okay, this last one is pretty awful, to tell the truth. And the reason it's pretty awful is because you're doing Bobby Bridge 3 times here. Awful. I will do the Bobby Bridges down here and then set this up. So in the first one, it's Bobby Bridge. Can't take out a greatest common factor. So we're looking for 2 numbers that multiply to 8 and subtract to 7. It's 8 and 1. So we have 2m squared. I'm going to decompose this. 8 and 1, remember. So it must be minus 8m plus 1m. And then the minus 4. You're going to pair them up. You should get to the point where you can factor almost as fast as I'm doing this. In the first pair here, we have a greatest common factor of 2m, which leaves us with m minus 4. Then I have a plus sign. Greatest common factor here is 1. Still left with m minus 4. Hey, look, we got the same thing. So it's m minus 4, and then 2m plus 1. Okay, that's the first one. In green, I'll do this one. You're looking for 2 numbers. This is Bobby Bridge again. You're looking for 2 numbers that multiply to 36 and subtract to 5. It's not the easiest one to do. I'll just tell you, because I don't want to waste time here, it's 9 and 4 multiply to 36 and subtract to 5. So you're going to decompose again. 6m squared minus 9m and plus 4m equals negative 5m minus 6. We're going to pair that up. So the greatest common factor here is 3m. We have 2m. 3m times 3. Okay, and then here we have plus 2 as our greatest common factor. And then we have 2m minus 3. We got the same thing. Great. 2m minus 3. 3m plus 2. Okay, if we look at the top, it's another Bobby Bridge. 2 numbers that multiply to 4 and also add to 4. Multiply 4 and add to 4, 2 and 2. So we're going to decompose 4m squared. Decompose that 4m into 2 and 2, so it must be plus 2m plus another 2m plus 1. Pair that up. First two, greatest common factor is 2m. You're left with 2m plus 1. Greatest common factor here is 1. You're left with 2m plus 1. And it worked. We have 2m plus 1 in both brackets, and you're left with another 2m plus 1. You could make it 2m plus 1 squared, but I'm not going to do that because I think it's easier when I do the ninja slicing. Okay, so I'm going to rewrite this. Basically, this first one here actually was this m minus 4, 2m plus 1. This green one here, right, this is that. So I end up with 2m minus 3 and 3m plus 2 divided by this top one was this down here, 2m plus 1, 2m plus 1. This last one's not Bobby Bridge, it's just a greatest common factor. Greatest common factor is 4, and you're left with 3m plus 2. Again, probably you don't want to do this, but just so you don't get confused, I will now flip the whole thing. I know that makes a lot of extra work. I know that probably 1% of you will do this. If you're not going to do this, be careful. You do not want to miss some of the MPVs. And if you do skip one of these steps, many of you will miss some of the MPVs. Okay, we're ready for MPVs. We're looking at all the denominators. So there's a lot of them here. Alright, let's start here. These are the same. So you have to figure this out. If 2m minus 3, that can equal 0. I guess I'll write it up here. 2m minus 3 cannot equal 0. So I'm going to add 3. We have to solve this, right? So I add 3 to both sides. 2m cannot equal 3. Divide by 2 both sides. M cannot equal 3 over 2. So that's one of my MPVs. M cannot equal 3 over 2. Okay, the next one. 3m plus 2. You might be able to do this without doing the little equations, right? But sometimes it takes a while before people can do that in their head. So you got to take 2 away from both sides, so 3m cannot equal negative 2. Divide 3 on both sides. M cannot equal negative 2 over 3. So m can't equal negative 2 over 3. Okay, up here, 4. Remember, looking at all the denominators. That's why I'm looking up here. 4. What would make 4 0? That will never happen, so you don't have to worry about it. 3m plus 2. Hey, we did that one here. Don't have to worry about it. 2m plus 1 and 2m plus... So as long as we got the 2m plus 1, we're done. So 2m plus 1 cannot equal 0. Subtract 1 from both sides. That means 2m cannot equal negative 1. Divide both sides by 2. M cannot equal negative 1 over 2. You don't need to write this all out for me if you can do it in your head, but if you get confused, that's the process. We're ready to cancel. Can I cancel out this 2m plus 1 and this 2m plus 1? No, you can't. It has to be 1 on top, 1 on the bottom. Luckily, we have 1 on top. Should I cancel both of them out? No, just cancel 1. Which one? Doesn't matter. I'll do that one. I see a 3m plus 2 and a 3m plus 2, and I believe that's it. So our final answer is 4 times m minus 4. I'll write it that way. All over 2m minus 3 and 2m plus 1. And then I have to write the NPVs. M cannot equal 3 over 2. I'm not going to be able to fit this. Negative 2 over 3. I can fit this. And negative 1.5. I've done it. I am amazing sometimes. Squishing something in like that. Can you believe it? That is incredible. Alright, I hope that makes sense, and I hope you know how to factor. If you don't, you are